All right, so you want to build something that moves, right? A robot, a little RC car, anything with an Arduino at its heart. You get all excited, you grab a motor, but then you hit the first big hurdle. It's not as simple as just plugging it in. So let's crack open the secret to getting things in motion.
I mean, it seems like it should work, doesn't it? You've got the Arduino, you've got the motor, why can't they just be friends? Well, if you try it, best case scenario, absolutely nothing happens. Worst case? Poof, you could fry your Arduino for good. So what gives? This question right here is exactly what we need to figure out.
You know, the whole issue really just boils down to a massive mismatch. It's a classic power struggle between what the Arduino can give and what a motor desperately needs.
Okay, think of it like this. Your Arduino is the brain of the whole operation. It's incredibly smart, it makes all the decisions, but it's not very strong. It works with tiny, low-power signals. A motor, on the other hand, that's pure muscle. It needs a huge gulp of electrical current to do any real work, way more than the Arduino can safely dish out. Trying to power the muscle directly with the brain, well, it's just a recipe for disaster. So if the brain can't talk directly to the muscle, how do we get anything done? We need a go-between, a translator. And that brings us to the absolute hero of our story today. This little board right here is the L298 Motor Driver, and it is a lifesaver. Its whole job, its entire reason for existing, is to be that safe, strong bridge between your low-power brain, the Arduino, and your high-power muscle, the motor. It listens to the quiet little whispers from the Arduino and turns them into loud, powerful commands that the motor can actually understand and act on. And that's the core idea. Seriously, if you take away just one thing, let it be this. The L298N is the bridge. It connects the delicate, smart brain to the powerful, current-hungry muscle, and it lets them work together in perfect harmony without either one getting fried. But this bridge does way more than just connect two things. It gives you some amazing control. With the L298N, you can tell your motor to spin forward, you can throw it in reverse, you can stop it on a dime, and, this is the really cool part, you can control exactly how fast it spins. It's basically a complete command center for your motor. So how in the world does it do all that, especially that really neat trick of going forwards and backwards? Well, the magic is hidden deep inside the main chip, in a really clever circuit with a pretty cool name. It's called an H-bridge. Now, don't worry about the complex electronics, you just need to get the main idea. An H-bridge is basically just a set of 4 switches inside the chip. And by flipping these switches in different combinations, it can completely change the path the electricity takes to get to the motor. Let's picture it. The Arduino sends a signal, and the H-bridge flips its switches into one pattern. The electric current flows through the motor from, let's say, left to right. This flow makes the motor shaft spin in one direction. We'll just call that forward. Simple enough, right? Now, for the magic. The Arduino sends a different signal, and the H-bridge instantly flips its internal switches to a new pattern. Now the current is flowing through the exact same motor, but in the opposite direction, from right to left. And just like that, the motor starts spinning backward. It's such a simple and elegant way to get total directional control. Okay, so the theory makes sense. The L298N is our bridge, and it uses an H-bridge circuit to work its magic. But how do we actually use it? How do we wire this thing up and start sending commands? Well, it all comes down to understanding the pins. Think of this table as your roadmap. Let's just walk through it real quick. IN1 and IN2, those are your direction pins. You hook those up to any of the Arduino's digital pins. ENA is your speed control, or enable pin. That one has to connect to a special PWM pin on the Arduino. Now this is super important. The 12V input is where the motor gets its power, and that needs to come from a separate external power supply, not your Arduino. And finally, ground, or GND, connects everything together. All right, we're wired up, we're powered up, we're ready to go. Now for the really fun part, telling the motor what to do. This is where we get into the code and start sending signals to those IN pins we just connected. And you know what? The logic is beautifully simple. It's almost like a secret code. You want to go forward? You send a high signal to IN1 and a low signal to IN2. Want to go in reverse? You just flip them. Low to IN1, high to IN2. And if you want to slam on the brakes and stop, you just send a low signal to both. That's it. Here's exactly what that looks like in real Arduino code. That command, digital write, in1 high, is literally like flipping a switch on for that pin. So by setting in1 to high and in2 to low, we're telling the motor driver, execute the spin forward command, right now. And to go backwards, it's just as easy. We just reverse the commands in our code. We tell IN1 to go low and IN2 to go high. The H bridge inside the chip sees that, flips its switches, and the motor immediately starts spinning the other way, all controlled by two simple lines of code.
But what about speed control? That's where our ENA, or enable, pin comes into play. Instead of just a simple high or low, we use a different command, analog write. This lets us send a value anywhere from 0, which is totally stopped, all the way up to 255, which is full throttle. So a value of 200, like you see here, is telling the motor to run at about 80% of its maximum speed. It gives you that fine-tuned, precise control.
So there you have it. The L298N isn't some big, scary mystery. It's the essential component, that bridge, that totally unlocks motion for your Arduino projects. You now know how to control a motor's direction and its speed. So the only real question left is, what amazing thing are you going to build with this new power?